Dude, I called it.
And we're back. There we go. Okay. Now let me start off by making a few announcements. I wanted to kind of talk through reminding you guys about working from home if you need to, right? What do I mean by that? I'm not sure if you guys caught this, but the quarantining rules have changed a little bit in the past couple of days since we've been back. There are basically two sets of rules. One's if you are vaccinated, one's if you are not vaccinated. One's if you are fully vaccinated, and one's if you are not fully vaccinated. Okay? There are two sets of rules. If you are fully vaccinated and up to date, right, then that includes, and that's even got like the booster in there. Like if you have your 2 shots and you have gotten your booster, or you have 2 shots and you are not eligible for your booster yet, like it hasn't been 6 months yet. So if you are fully vaccinated and you get contact traced, then all you have to do is just wear your mask for 10 days, which is what the old guidelines were even if you weren't vaccinated. But that has since changed. If you are unvaccinated, if you're not vaccinated, and you get contact traced within the school, then you are out for 5 days, no matter what, okay? If you are not vaccinated and you get contact traced within the school, you are out for 5 days. Then the next 5 days, you have to wear your mask. You can come back after 5 days, but then you have to wear your mask for 5 days. So 10 days total, okay? Which I feel like is going to start happening a lot more. So if you are out for those 5 days, and let me remind you that if you are quarantined and you are not sick, the expectation is that you are staying on top of your assignments. The expectation is that everything should be getting turned in if you are home. Is that clear?
Yes.
Okay. And let me remind you, because I literally in between classes got an email saying, I'm going to be out. I don't know what to do. And it's like, how? How do you not know what to do for my class? Because I've explained it several times. So I'm just going to go through it one more time so that there is no question about it. So remember, this is my campus homepage here. If you are out on any day, I post everything online, right? So like say you were out yesterday. You just click on that day, click on Monday. That's the day we were out. There's section 5.4. There's the guided notes that I handed out yesterday. There's the YouTube video, just like I'm doing right now. There's the just a PDF copy of the notes. If you'd like to print it out, you can. I don't care, whatever. And then there's the book page, okay? Everything is there for you. I am going to start getting angry and getting a little frustrated with people that come back and say, so what do I need to make up? Stop doing that. You know what you need to make up. You should have been doing it ahead of time. The rules are different if you are quarantined and not sick. If you are sick, that's a different story. Then come back and you have time to work on your work. If you are just quarantined, you must be staying on top of your assignments. The due dates are not changing for you just because you're quarantined, because everything is fully online for me. You can do everything online. You can submit online. Everything is fully online. There is no change from in-person to online in terms of my class. Now, other classes that may be different, but my class, I video every single lesson, so you should be able to stay up to date with everything. Is there any questions about that? Because again, I'm still getting emails on kids saying, I don't know what to do. Stop doing that. Yes, you do know what to do. You're just lying to your parents and saying, oh, they don't post anything. Yeah, that's a lie. Because at the end of the day, I have to call a parent and tell them that their kid is lying to them. Okay, stop doing that. Stop doing that. Are there any questions about that? Do I need to clarify anything? Okay, so if you get quarantined, are you just going to wait till the last minute to do all of your assignments? No. If you are quarantined and you come back and have done nothing, you get zeros for all of those assignments. And I'm going to be pretty frustrated with you. Yeah.
So if you're quarantined, are you allowed to skip ahead a couple days?
Well, I only post things like that day.
Oh, okay.
So like tomorrow, I mean, even today, there's a link there, but all it is just the guided notes and the homework.
Oh, okay.
at the end of this lesson today, I'll go in and post a video in the PDF.
Okay.
Does that make sense?
Yeah.
And I will be posting them like at the end of second period. So somewhere around like 9:30, they'll get posted. Because I've had kids do that too, like, hey, your assignment's not up yet. Well, yeah, I haven't made the video yet. It's not second period yet. Okay. It's only like 8 or something. There. All right, so I digress about that. Hopefully there's no more issues about that. But I wanted to have that on record. All right. So no matter how you chose to do this problem, whether you chose to eliminate with the x's or you chose to eliminate with the y's, I hope we didn't just multiply by big numbers. Like, let me say this. Could you have multiplied by 6 and 9 to get them to eliminate? Yeah. Is that the best choice? No. By far, no. Okay? The best choice would be to multiply by 2 and then 3. Now, what do I have to do to one of these numbers?
Make the 2 negative.
Make one of them a negative, right? Yeah, you made the 2 negative, so I'll do that. We'll make the 2 negative. And why do I do that? So that we can add, because we need opposite signs, right? So we can add later on. Negative 18, positive 30, negative 48. Positive 18, negative 30, be careful, negative 48. Now, watch out. I bet a lot of you said everything's going to cancel. Is everything going to cancel? No. My x's cancel. My y's cancel. Now, when that happens, this is a special case, right? If one of the x's or y's didn't cancel, I'd end up getting like 1 point, right? An x value and a y value. Because both x value and y value canceled, this is a special case. It's either all infinite solutions or no solutions. Question?
No, I'm good.
Okay, and then we add down here negative 48 and negative 48 does not make 0. Negative 96. Now, okay, is 0 equal to negative 96? No. So there are no solutions. You could write out no solutions, but the symbol is fine. Okay, are there any questions on last night's homework? Hopefully it was pretty easy. Yeah. In my opinion, it was pretty quick. I know a lot of you got it done in class yesterday, but yeah.
So the 0 equals 0, that's not infinite.
Yeah, it is.
It is?
Yeah, because it's a true statement. So that's infinite solutions.
Alright.
Yeah.
And then what would be like here?
Yeah.
So like I got like one of these, whatever these R looking things are, right here. Is that right? It's like
For 5?
Yeah.
Watch out there.
Like where do I make
That should have canceled. You dropped the negative here.
Oh.
That should have all canceled.
Oh yeah. My bad.
Does that make sense though?
Yeah. It makes sense.
Any other questions on the homework? Okay. Let's get to our guided notes then for today. Pass these out. Yeah, we got graph paper out. Okay. Thanks.
Yes.
I should have watched the whole game last night.
Yeah, so did I.
I wanted to see Ben's very last game in high school.
Me too. It was rigged.
Great.
No, it wasn't. It was turned for. You see, also big record just gave the ball.
Yeah,
I mean, you're
of course they got picked with
So
10
he can
seconds
get
left.
the kneel down at the end.
So Baker getting sacked 9 times was all rigged?
Yeah.
Yeah, he's just a bad
At this
player.
point, no one cares about him anymore.
Oh, got it.
No, Baker.
Dude, Baker.
Baker don't buy.
I remember when Baker was like,
Gonna be our
he
savior.
was the second coming, man. He was like the savior.
He was good. He was awesome.
He was?
He
Because
was.
I don't remember being that great. I don't know if he was ever
Last
that
year,
good.
really destroyed you. That was your defense.
Right.
That was the defense.
That was helmet swinging Miles Garrett.
Back to the
All right.
That was Helmet Garrett.
All right. Now we are going to take a kind of a sidestep here. You know, we've been talking about systems of equations for a long time. But now what we're going to do is kind of shift a little bit and talk about inequalities. Inequalities. You know, we have been talking about multiple equations going on at the same time. But now what we're going to talk about here is inequalities. Not equalities, not equations, but inequalities. Now, how do we graph inequalities? Now, think about this. In the first semester, we talked about, 2x plus 5 is less than 10. And we graphed on a number line. We had open circles, we had closed circles, the arrow pointed left or pointed right. But it was all about, okay, all points to the left or all points to the right. So what if I add in a second dimension? What if I add in the y value here? What does that mean? Well, now it's no longer just an x, but it's an x and a y. Okay, that's what we're going to be looking at today. Now, the first thing that we do, like always, is, figure out, once you get an answer, how do you check that answer? Like, how do you check that answer? Taking a look here. What if I had gotten this inequality and I wanted to check that answer? What would you do with this answer, this negative 2 comma 4? I don't know how I got there yet. We haven't gotten to that point. But I say, okay, negative 2 comma 4 is my solution. How do I check that?
Well, you put negative 2 in for the x, and then you put 4 in for the y.
And we just see if it comes out to be a true statement, right? We remember that this is x and this is y, so I'm just going to plug it in. 4 is less than 2 times negative 2 plus 1. And we see, okay, 4 is less than negative 3. Is that a true statement? No, that is not a true statement. So we say, I don't know how we got there, but this is not a solution. Okay? Please don't do the no solution symbol, because that's not technically true here. Are there solutions to that inequality? Yes. Is negative 2 comma 4 one of them? No. Let's do that again. Okay, same thing. I don't know how we got 4 comma 5. I don't know how we got that coordinate. But let's say we got there. We needed to check that answer. Okay, let's plug it in. Again, this is x and this is y. 5 is less than 4 plus 1. Is that a true statement? No. Be careful with that. I just say 5 is less than 5, which is not a true statement. So we say again that this is not a solution. What would I do to the inequality to make that be a solution?
You can have the point 5, 5.
I could, but to the inequality though.
Oh.
Just to the inequality, just to the symbol. Make it equal to. And look at example C. That's all I did to change from B to C. Just change it to an or equal to. And that now is it a solution? Yeah. So we say yes, it is. I'll just put a yes. Yes. Really excited. Yes. Mr. Parker, I'm just going to warn you, everything you say is being recorded. What's up? I think go back to this. Go back to that test. I think he went to that student administration site.
Oh, I didn't like that.
I sent it.
If you're open,
You what? Crazy.
Yeah, I was
Algebra 1, and then 3 dots. Release. Scroll down.
So it'll be all, wouldn't it be all the freshmen are done at the same time?
Why do you have that?
I don't
Why do you
know.
have all this?
I don't know.
There's something wrong with that. Because he's my kid.
All the freshmen are on the one site.
See, that's a time problem.
Well, they also don't.
That's not you. That's not just your kids. Go show you that.
We'll go to the Jets.
So yeah,
That's
I have
what I
time.
was thinking, is Jack.
I don't want to get it.
We're gonna get Watson.
No.
So-
That's above my pay grade.
But all the freshmen are
It's
now.
either Watson or Carr.
Yeah.
Well, remember, I assigned
That's why they're not
mine.
choosing
My
Russell.
students, for some reason, are showing up
Or
on
you're
yours.
Russell Wilson.
They shouldn't be. I should only be able to have my students.
But I
You
didn't
should
select
only-
my class.
It doesn't matter. You shouldn't need to.
Oh.
It's only available, like, only your students should be available to you.
Oh.
See, that's gonna mess up your data if it's not.
I gotcha. Thanks.
I got you. All right, let's, sorry about that. Sorry for the delay. This 7, 3. Let's check 7, 3. So the y value is 3. Is 3 less than or equal to 6? Yeah. So we say again definitively that yes. I don't know how we got there. I don't know how we chose that yet, but we do know that 7, 3 is a solution. Now, again, thinking back to just inequalities with one variable, we had said that the solution was like a left or right thing, right? All points bigger than 3 or all points less than 3. Infinite set. Now, looking here, when we're talking about a linear inequality, what it does, once you put it on a coordinate plane, it describes like a half plane. That's what we call it here, a half plane. Because as soon as you draw a line in a coordinate plane, it separates it into 2 pieces. Top, bottom, left, right, however you want to describe it. Okay? Every point within that region is a solution to that inequality. Okay? Every point is a solution in that inequality. In that region is the solution to that inequality. You have to kind of think about it as like an area, a region, an area of solutions. It's not just one solution. It's not just one point. It's an infinite set of points. It's a lot of points. Okay? There's a whole set of points that's going to be our solution. The boundary line of the region is basically us graphing the equation that we had and then deciding, do I want points above the line or do I want points below the line, and how do we describe that? Okay, well, let me show you this diagram here, which you have on your papers. I've got the colored version up on my screen here. But you see 2 inequalities going on at the same graph. We got the green one, the red and green one. The line here is the boundary line. Do you notice how it's a solid line? You have a solid line when there is an or equal to underneath the inequality. If there's an or equal to, it's a solid line. Think back. Remember how we wrote like a closed dot on the number line? Same type of thing. We had our closed dot. That's okay. We had our closed dot as a number line. That's the same type of thing. If we have a closed dot, or if we have an or equal to on our inequality, that's like a solid line here. Okay. When the inequality is written as an or equal to, less than or equal to, or greater than or equal to, it is a solid line. If that or equal to is not there, that would be like an open circle that we had before, right? If you're thinking of it like an open circle, that's just a less than or greater than. There is no or equal to, okay? So we graphed the line and we decided, is this line going to be an open circle or closed circle? A solid line or And now this is our open circle, a dotted line, a dashed line. Okay? This is kind of like that open circle, that dashed line, the dotted line. And then we say, okay, do I want points above the line or points below the line? Well, that all depends on whether it's y is greater than or y is less than. If y is greater than, we shade above. If y is less than, then we shade below. And the shaded region is the solution region. Like if I'm taking a look at this region down here, for the blue inequality, every single point is a solution down there. If I plugged in any one of those coordinates down there in that shaded region into the inequality, it would be a solution. It would come out as a yes, it is a solution. Okay? So flip it over onto the back. Let's talk through the steps of graphing these inequalities. First step. Now this first step is sometimes done for you. If you look at example A, this step is done. If you look at examples B and C, you're going to have to do it. First thing, solve for y. Solve for y. See if y is alone. And it is on our first example, but not for the other two. Second step, graph the boundary line. And this is what we kind of practiced yesterday. What's the slope? What's the y-intercept? Graph the line. You have to then decide, do I want to use a solid line or a dotted line? Remember, solid line is the or equal to. If the line is underneath, then it's a solid line. If it's not there, then it's a dotted line. And then lastly, and this is really important, this is what separates an equation to an inequality, you must shade. Shade the region where the solutions are. Shade above for greater than or equal to. Shade below for less than or equal to. Okay? So let's do that. Okay, step 1, check, done. Step 2, let's find the slope and the y-intercept and graph the line. What's the slope? 2 over 1. Slope is 2. So it's 2 over 1. What's the y-intercept? -3. Okay, so let's graph. I go down here to -3. And then I make my points using my slope. Up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. I could also go down left as well. Now, at this point, once you make your dots, you then have to decide, okay, is this a dotted or solid line? Somebody tell me.
Solid.
Solid. What tells you that this is a solid line?
Because it has the or equal to symbol.
Good. Because this has the or equal to symbol. This is a solid line. If that or equal to was not there, this would be a dotted line. Now I decide, do I shade above or below?
Below.
Why do you say below?
Because it's less than or equal to.
Yeah. The fact that this is a less than symbol tells us to shade below. So I'm going to go to my highlighter here. Now you can use crayons, colored pencils, whatever, highlighters on your homework. I really don't care. You could also just use your pencil to shade. But please don't forget to shade. That means that any point within that region is a solution. Like for example, is 4, 0 a solution? Yeah. Is 3, -3 a solution? Yeah. If I plugged those points back in, I would get a yes. What about 0, 0? No, that would not be a solution. If I plug that in, 0 is less than or equal to -3. That's not a true statement. 0 is not less than -3. Okay? So that's how you could check your answer as well. Let's do another one of those. All right, well, I need to do step 1 in this case. I need to solve this for y. What's my first step in solving it for y?
Subtract 5x on the side.
Yeah, let's move that 5x over to the right side. So we subtract the 5x. Oh, almost wrote less than. 2y is greater than, and I wrote -5x minus 8. And what finishes this off? Divided by 2. And everybody gets divided by 2. So y is greater than negative 5 over 2x minus 4. Okay, step 1 is done. Step 2, graph the line. Now, could I write negative 2.5? Watch out for that because, again, this is a fraction. I want it as a fraction for my slope. Decimal, that would be, if it were a word problem, that would be okay. My slope is negative 5 over 2. My y-intercept is negative 4. Okay, I go down here to negative 4, make my dot. Remember that this is a negative slope, down 5, right 2. Or up 5, left 2. 1, 2, 3, 4, 5, 6. Now, is this a dotted or solid line? Dotted, because there is no or equal to. Like this would be an open circle. That means that that boundary line is not included in our solutions. Shade above or below. Now, be careful here. Where do I go to find the above or below? You go right to where you had your y equals. That's the step where you need to decide whether I shade above or below. Now, coincidentally, it actually ends up the same symbol as my original problem. I will not do that next time. Do I shade above or below? Above, because it's greater than. I shade above. If you ever question yourself and say, did I shade that right? Did I do that right? Just pick a test point. Should 0, 0 be a solution? Yeah, so run it. Run that point. Okay, 5 times 0 plus 2 times 0. Well, that's all 0 on the left side. Is 0 bigger than negative 8? Yeah. Checks out. Okay, let's do one more of those. Can somebody tell me the easiest way to solve this for y? I know from because of past experience, I might move things over to the right. What's the easiest way to solve this for y?
Subtract 2 and then subtract 4x.
That wouldn't be the easiest way. There's an easier way. What's the easiest way to get y alone? Gio?
You could subtract 1y to the other side?
Add it.
Or
Because it's already a
yeah,
minus. Yeah, all I need to do is just add the y over to the other side. Will that get y alone on the right side? Yeah. 4x minus 2 less than or equal to y. Now here's the deal. Y needs to be on the left side. Plus 2, isn't it? Y needs to be on the left side. Yeah, that should say a 4x plus 2. So I got to flip it. And the sign, yeah. So this should be a y is greater than or equal to 4x plus 2. And that's the line that I graph. Slope is 4. B is 2. Rise 4, run 1. Down 4, left 1. Is this a dotted or solid? Solid, because of the or equal to. Shade above or below? Above. You might be tempted to say below because of this inequality. But remember, you have to wait until here. That's where you decide, oh, it's greater than. Shade above. that means that any point in that region would be a solution. Don't trust yourself. You're second guessing yourself. Pick a test point. I don't know, 0, 0 is pretty close to my line. Maybe I screwed up. Let's go 2, 2. Should 2, 2 be a solution? No. So let's check to make sure that it's not. 4 times 2 minus 2 plus 2. All right, so this is 8 minus nothing. Right? Because that cancels. So is 8, whoa. Is 8 less than or equal to 0? No. So this checks out. I didn't think that 2, 2 would be a solution. So yeah, it does what I thought it should. 2, 2 should not be a solution, and it turns out it's not. And again, that's just a check. That's just a quick check to make sure you shaded in the correct spot. All right, last thing that we're going to do is kind of flip it now. We're going to take the inequality from a graph. Okay, we're going to turn it into the equation. Feel that? Perfect. All right. So here's what I'm going to do first. I know my y has to be on the left side. Let's decide what our inequality is going to look like. Is this going to be a greater than or less than? Greater than. And I see that because it's shaded above. Is this going to be an or equal to or not?
No.
Not. Because we see that by the dotted line. It's greater than because this is shaded above. And there I do not need to add in the or equal to because this is a dotted line. Okay, now we just have to figure out our slope and my y-intercept. Well, let's find 2 nice points. And let's find the slope between those. 1, 2, 3. 1, 2, 3, 4. So what's my slope? 3/4. Rise 3, run 4. Do I need to change that into a negative slope? Is this a negative 3/4 or a positive 3/4? It's positive. Leave it positive. And then what's my y-intercept? 1. Positive 1. Questions about that? Yeah.
I did something wrong, obviously, but I went from -1 on the x-axis to positive.
That's not really at -1. It looks like it's crossing right here.
Oh.
Yeah.
Okay. No, cool.
Let's do one more of those. Okay, let's first decide the inequality. Greater than or less than? Less than, shading below. Do I need to add in the or equal to?
Yep.
Yeah, it's a solid line. Okay, from here on, it's just, our equations. Now, you might be saying, well, wait a sec, we can't use rise over run because the scale of the graph is not 1, it's 2. But because both scales are 2, I can use the boxes. I go down 1, right 2. So that's a negative slope. Down and to the right is a negative slope. So I'm going to say down is a -1. Right 2 is a positive 2. And then what's my y-intercept? -5. -1/2 x, because remember, these are going by 2's. So this is a -6. So that looks like to be a -5. The homework is on the board here. Page 279. Numbers 3 to 11 odd, 21 to 23, 33, 34. Will you have to graph? Did we have to graph in our notes today? Yes. Will you have to graph in your homework today? Yes. If you need extra graph paper, there's still some left down there. You should probably have some left in your notebook if you need it. That's all I've got to say about that. Any other questions? Turn off the video. I'll post it.